Okay, let's start.
All right. So hello, party people, and welcome to Why Defragmenting Your Indexes Isn't Helping. I'm Brent Ozar. I'm a Microsoft Certified Master, which just means that I've made a lot of expensive mistakes with SQL Server over the years, and now I get to help y'all avoid some of those same mistakes. The reason that you're here is because performance isn't good enough. Let's just set the stage. And the reason that you're here is to make a real meaningful difference in your SQL Server's performance. This isn't about just rearranging chairs in your office. You want the kind of difference that users will notice, that they will high five you for in the hallways, that they'll actually get excited when they see the difference that you make in the SQL Server's performance. The kinds of people who come to this session say things like, fragmentation is bad and I need to fix it. And in the span of this presentation, in this next hour, I'm going to grab you by the shoulders and shake you and challenge some of your basic assumptions about the things that are important on your SQL Server versus the things that aren't really all that important. Let's start with how SQL Server stores data. And I keep pages on my office here just so that I can remind myself. SQL Server's data is a lot like pieces of paper from a spreadsheet. Most of the things that SQL Server does are stored in 8K pages. Each one of these 8K pages holds your data, holds rows from a clustered index or from a non-clustered index. And for starters, let's think about a phone book. Let's think about a list of everyone who lives in your city. And phone books were organized by last name, then first name. So my database is really a bunch of these 8K pages with alphabetized people. The A's, the B's, the C's, all lined up in pages. And on the screen here, you can see a few pages out of my phone book. Now, because when you publish a phone book, those pages are absolutely full. Normally, you don't leave empty space, and when you go write a phone book, you cram that data in as tightly as you possibly can. And you can see people's last names there on the page, so you can see that page 4096 has Hall through logins. Page 4097 has logins through Messina. Page 4098 has Messina through Oates. A new person moves to our town, and their name is Michael McDonald. So I need to go to the page where Michael McDonald needs to be stored, but there's no empty space left on that page. It's not like I can somehow write sideways and fit him into the margin. There's no space left. So what SQL Server does is it needs to allocate a brand new page to store some of the people from that page of the phone book. This process in SQL Server is called a page split, where SQL Server takes some of the rows from one 8K page and puts it on a different page. Now, right here on this slide here, I have two problems in my database. One problem is that that new 8K page I allocated won't be right next to the page I had before. My whole database is nothing but these 8K pages. They're all lined up in order, one 8K page after another. And if I need a brand new empty page, it's not like there's one that I can just make in the middle of the file. I have to start writing my phone book parts in a different part of the database. In this example on the slide, that's page 9144. The third page on the slide is a different page order than the rest of them. My 8K pages aren't in order. That problem is called external fragmentation. Outside of the database, the pages aren't stored in 8K order. On our storage, those pages are kind of shuffled around randomly. The other problem that I had is that when I did the page split, that leaves empty space on the page. This is called internal fragmentation, when I have empty space inside my 8K pages. To monitor when this stuff is happening, there are a few different ways that you can do it with things like perfmon counters and DMVs. And the way that you monitor each of them is different. The way that I monitor for page splits involves a perfmon counter. Page splits per second tells me the number of times that SQL Server ran out of space on an 8K page and had to split it off to another 8K page. The next one, external fragmentation, is the DMV, sysdmdb physical stats. And then for internal fragmentation, how much empty space I have on each page, that's yet a different DMV. People just think of fragmentation and they think of all three of these numbers. And so they think in order to head off the problems, they're going to start monitoring for page splits. Page splits sound like they're a bad thing. It sounds like when I ran out of space on an 8K page and I had to go allocate another 8K page somewhere else in order to monitor for those rows. That sounds like it's a bad thing, but there's a terrible error, I call it an error or a bug inside a SQL Server, that's not what page splits really mean. And to prove it, what I'm going to do is I'm going to create a brand new table from scratch with no data in it whatsoever. I'm going to call it my customers table. I'm going to go check to see how many page splits I've had, because that perfmon counter there from SysDMOS performance counters, that counter for page splits is cumulative. Since your SQL Server restarted, SQL Server is constantly tracking how many page splits it's had. So I'm going to track the number of page splits that I've had. Then I'm going to insert just one row. And then I'm going to check the perfmon counter again to see how many page splits I've had. That number shouldn't change, because when I'm adding the first brand new row to an 8K page, there's nothing in it. It's not like this page could have split. There were no rows in this table. And yet, when I go look at the perfmon counter for page splits, SQL Server goes, "You just had a page split." I always use a guy's voice for SQL Server because he's dumb and stubborn and he refuses to ask for directions. He's all, "Trust me, I got this," when he doesn't usually got this. So SQL Server's number for page splits goes up. SQL Server says, "Yeah, you just split a page." No, I didn't. I couldn't have. But to SQL Server, here's the screwy part. Remember how I said that when we had to take some of the rows from an 8K page and go allocate another 8K page to put them somewhere else? Here's what SQL Server's really tracking. He's tracking the number of times that you ask for a page so you can load new data into a table and you will see page splits like crazy, and that's not a problem. I see people worried about page splits all the time, and they're in SQL Server turning dials and pushing buttons trying to fix page splits. You can't. There's no way to stop having page splits from happening, because page splits also include the number of 8K pages that we allocate brand new for objects every time that someone creates a temp table. When they create a temp table and start loading data, guess what you're having? Page splits. But it's not really page splits at all. Whoever made this counter just didn't understand what they were measuring. Now, there are more accurate ways in order to track page splits, but what you have to do is you have to look at extended events, and then you have to track it on an object by object basis, like across all of the 8K or all the tables that you have. And if you're just now learning this for the first time, buckle up. It's about to get way worse than that, because there are problems with the other numbers as well. The reason that people usually think that a page split is bad is because it's taking some of the rows and moving them over to another 8K page, and that 8K page isn't in physical order. That would mean that if you had to read from a table, you'd be jumping around all over the place on storage because your data wasn't nicely and evenly all laid out in a row. Does that matter? If you're in this session, you've probably been reading advice out on the interwebs for the last decade or maybe even 2 decades, and there were times when some of this stuff did matter, and that's when some of these blog posts were written. But let's go back now and think about the questions on this slide and really dig into them deeply. Does external fragmentation affect the speed of your maintenance jobs? Does backups take longer? Does CheckDB take longer? Do your index rebuilds take longer? Does external fragmentation, if the pages aren't sitting next to each other, does that mean that queries reading from memory are going to be slower? Does it mean that pages read from disk will be slower? And then finally, how do you actually fix that problem? Well, let's look at the answers. Does external fragmentation affect your maintenance performance? Not even a little. Your backups don't care about the contents of the data they're backing up. They simply read from the beginning of the database all the way through till the end. It doesn't matter if the tables inside are all jumbled up in order. SQL Server is simply backing up every 8K page in order, start to finish. Same thing with restores. Same thing with CheckDB for the most part. Index rebuilds, it's actually not going to change the speed of your index rebuilds except if you try to fix it, and we'll get into that here in a second. Will queries reading from RAM take longer if your pages on disk are out of order? Remind me, what does the R in RAM stand for? Random. Random access memory. The R in RAM, random access memory. It's not called sequential access memory. Your pages up in memory, you can fetch them from anywhere at any given time. There's no such concept as sequentially defragmented pages in RAM. There is for the engine itself. All its pages need to be in order. That's a separate discussion around startup and large page access. But as far as SQL Server is concerned, if you're servicing data from RAM, it doesn't matter whether the pages are on disk or not. What about if you're scanning 8K pages from disk? Okay, this is where your grandmother, when your grandmother was writing blog posts about Microsoft SQL Server and she wanted to try to make storage performance go faster, she would say that, "Son, we only have 1 gigabyte of RAM. And because we only have 1 gigabyte, we have to pull everything from storage." But think about that today. Your servers don't have 1 gigabyte of RAM. Your servers have 16 or 32 or 64 gigabytes of RAM. And so when you go to hit storage, if you're only asking for 1 page, if you're doing an index seek and then you're dive bombing in and only getting a few rows, it doesn't matter where that page is on disk. Where fragmentation starts to screw you is if the pages are stored all over the place and you need to do a scan. Come on now, if you need to do a scan, you're screwed anyway. If you need to go to storage and do a scan, it doesn't really matter if the pages are stored in order or not. And for that matter, they're not stored in order no matter what. To understand, let's dig a little bit deeper into what latency means. There's this Linux performance tuner who now works for Intel by the name of Brendan Gregg. And when Brendan was writing a book about performance tuning, he needed to put latency speeds in perspective for human beings. You and I can't understand milliseconds and microseconds and nanoseconds. So what Brendan did was he laid out a chart that said, let's pretend that one CPU cycle takes 1 second. It doesn't, but just for the sake of you and I understanding what time means, let's pretend that one CPU cycle is equal to 1 second. Well, accessing RAM, that's the line here on the slide that says main memory access. Accessing RAM is the equivalent of 6 minutes. You and I like to think that memory is fast. It's kind of fast, but what's really fast is modern CPUs. They can do so much work in such a short period of time. Memory's slower. Storage is even slower than that. Brendan says solid state disk I/O is the equivalent of 2 to 6 days. But you know what? If you have a lot of shared storage, if you have shared storage that's shared across multiple computers, Brendan's numbers of 50 to 150 microseconds isn't realistic. If you're dealing with shared storage, it's much more typical to see 1 to 10 milliseconds, which is equivalent to 1 to 12 months. And then if you have crappy storage, those numbers down there under 40 milliseconds to 80 milliseconds are more common, which is 4 to 8 years. Memory, 6 minutes. Storage, 4 to 8 years. Let's just play pretend for a second, that you work really hard about getting all of your 8K pages in order. And you go, folks, good news! Now when you query the systems, instead of each page taking 4 years, it's going to take 2 years. Nobody cares, because performance when you go to hit storage is so crappy that those incremental improvements don't really matter. Your people who are running data warehouse queries, they're not looking for an improvement on reports to go from a 60-second report to a 50-second report. No, they want to go from a 60-second report to a 15-second report. And fragmentation isn't going to be the thing that gets you there once you're on crappy shared storage. Users want memory-grade response times. They don't really notice the difference between 1 month versus 4 years. They don't notice the difference in performance for defragmented storage as opposed to memory. That's the part that they actually notice. So coming back to our lists, does this queries reading from disk, are they slower if you only need a few pages? No. Are they slower if you do big scans? Yeah, but in order to fix it, the fix is terrible. What we do to fix external fragmentation is we say to SQL Server, all right, we either want you to reorganize objects, which means pick up one 8K page at a time and move it single-threaded. Reorganizing shuffles a single 8K page around one at a time. Single-threaded, it takes absolutely forever. SQL Server basically goes to the last 8K page and moves it to the first available empty slot. Or if we're going to rebuild it, SQL Server reads from the old object and builds a brand new copy of the new object. If you're lucky, all the pages are in order. But the only way that they're in order is if you rebuild your indexes with maxdop 1. If you divide an index rebuild across multiple CPU cores, which most people do when they're on Enterprise. If you're on Enterprise and you rebuild an index, it's going to go parallel across multiple cores. And then you have really 4 different parts of copies of the object. That object is not all in a line at once. Plus, look down at the bottom of that slide, both of these operations, they're fully transaction logged, which means that everything that SQL Server does, it's writing out to the transaction log the changes that it makes, and those changes have to be copied over to your availability groups replicas, to your database mirrors, over to your SAN replicas that are replicated across different locations. All of this is a big, slow, ugly change that involves lots of downtime. Users get really frustrated because they're like, look, why are we rebuilding all these indexes every night, taking up so much time? And they don't even notice performance whenever we're done. So the way that we fix external fragmentation sucks even worse to users than real performance tuning does. They don't understand the difference that we made by improving external fragmentation. So when people get to this point, they say, okay, here's what I'm going to do. I am going to fix it by setting fill factor. What I'm going to do is I'm going to leave empty space on every 8K page so that when I need to go let Michael McDonald move into my town, there's going to be empty space left over on the page instead of having an absolutely packed in full 8K page. That's true. That's exactly what fill factor does. When you set fill factor, you are proactively leaving empty space on every 8K page. And the way that most people set fill factor is they set it across the entire server or database level. They don't set it on one index at a time. They set it across the whole database or the whole server to set the entire fill factor across the board. Let's say that, like with the Stack Overflow users table, it's a table that's clustered on an ID, starts at 1 and goes up to a bajillion. If your clustered index is sorted by ID, do you ever need empty space on those 8K pages? Are you ever going to go back and insert a row at an earlier ID? Of course not. No, you're not going to go back and insert ID number 1, 2, 3, 4, 5, and then go, time out. I missed -1. Let's go back and insert it -1. You never need empty space on a clustered index that's sorted by an ever ascending key. You don't need space for inserts. You do need space for updates. What if you have a nullable column? You have a column that defaults to null, and you do a whole bunch of inserts, and there's no space left on this 8K page. But then someone goes back and they update their profile, for example, and they update their profile. It used to be null. Now it's some kind of data. SQL Server doesn't have enough space for that. So then it's going to go split the page. It's going to take some of those rows onto one 8K page and some of those rows on the original 8K page. For updates, it is conceptually possible, especially if you have a bunch of null columns, so that when that value is first inserted, it's null. When it's updated, it's wider. When people do those updates, you'll need space. But how much? And how often does that happen? It only happens once per row. So why would I go back through all the history of a clustered index and leave empty space on every page for updates that will never happen again? Inserts, updates, deletes. Do I need to leave empty space for deletes? No, deletes actually make space. If you ever have deletes on a table, you're freeing up space that you can use in order to do updates. So it doesn't make any sense to set fill factor anything other than 100% on something like a clustered index. There are rare edge cases where you have nullable columns that are immediately gone back and widened out, but even then, you don't need it over time through all of the history of the table. It makes no sense to leave empty space back there. Okay, let's stick a fork in clustered indexes for a second, and let's talk about non-clustered indexes. In the Stack Overflow users table, there's an index on a column called last access date. On a column called last access date, Stack Overflow constantly tracks when the last time it was that you accessed the system. Every time that you touch a page at Stack Overflow updates your last access date. So if you imagine what this index looks like, it's just a list of last access dates with the ID for each user. Do we ever need space on these 8K pages? Every time that someone logs in, what's the date and time they're logging in? They're not logging in yesterday. It's not like right now I'm going to say, go set Sam's last access date to last Thursday. No, people are always accessing the system right now. So if I have an index on, say, last access date, after 5 minutes, what does this 8K page look like? Every time each one of these users logs in, we are picking up their row and we're moving it away. We're moving it somewhere else to right now, for example. After 5 minutes, this page looks like Swiss cheese. There are holes all over the place on this 8K page. You would never want to leave empty space on this page. The page is constantly evacuating itself. And yet I know people who set fill factor to leave empty space on every page, and they go, I don't understand. My indexes keep fragmenting. Every day I have all these problems with fragmentation. I keep playing with fill factor, trying to fix it, and it's not working. Yeah, because you haven't even looked at the contents of the pages that you think you're trying to fix. It doesn't make sense to leave empty space back on older pages. There's a reason that databases default to 100% fill factor, and it's a really good reason. You want your pages to be chock full of juicy data. You want your pages to be absolutely as full as possible. And when you set your fill factor lower, you know what you're actually doing? You're setting fragmentation. You're telling SQL Server that you purposely want to fragment your tables. You're saying you want your database to become larger. If I pack every one of these 8K pages as tightly as possible with that sweet, juicy data, then my database is as small as possible. My backups are faster. My table scans are faster. My index rebuilds are faster. But when you purposely leave empty space on every 8K page, let's say, just to say, that you set fill factor at 80%, and you're going to leave 20% empty space on every 8K page. You just made your database 20% larger. You made your backups take 20% longer. You made your restores take 20% longer. You made your index rebuilds 20% longer. Updating statistics 20% longer, please. Table scans. I'd like my long, slow table scans to be 20% slower, please. Who in their right mind would do that? And yet I see consultants recommending that, saying, oh, you know what your solution would be? You should make your queries 20% slower. See, if the pages aren't in order and you got to scan them, you want those scans to be fast, so make them 20% larger. That makes no sense. Then they're actually causing internal fragmentation by leaving empty space on every single 8K page. They're making everything worse. And the fix for internal fragmentation is completely different. Now, this lowering of fill factor, setting it down to 80%, or whether you have empty space on every 8K page, let's take that quiz again. If you leave empty space on every 8K page, are your maintenance tasks longer? Will queries reading from RAM be slower? Will queries reading from disk be slower? And in this case, everything is a resounding yes. Your maintenance tasks are worse. And now you've even slowed down reading from RAM. Because if you need to scan an object that's stored up in RAM, it's now 20% more 8K pages. And you know what? You now have 20% less RAM. People complain all the time. Oh my God, my boss is so cheap. They won't give me enough RAM on my servers. And then I look at their fill factor and they've set it to like 80%. You are robbing yourself of 20% of your RAM because SQL Server caches these 8K pages up in memory. If you're dumb enough to set fill factor lower, these 8K pages are caching empty space. That's your RAM. You made your RAM 20% smaller. We're the problem. When we look at fragmentation and we set things like fill factor, we are making things worse. Every night when we rebuild indexes and reorganize indexes, when we're scribbling like crazy trying to make things better, when we're making our nightly maintenance tasks take longer, we are the ones who are making things worse. There's a great joke in the airline pilot community. In the airline pilot community, they talk about modern planes being so advanced that there are only two things in the cockpit. There's the pilot and there's a dog. It's a pilot's job to feed the dog. It's the dog's job to bite the pilot if he tries to touch anything. SQL Server needs a dog because we're in there going, hey, you know what? I bet this thing would be faster if I played around with fill factor. Hey, you know what? I bet this thing would be faster if I rebuilt my indexes every day. We're in there with a screwdriver touching everything that's inside the airplane cockpit, and we are the ones that are actually making things worse. This is why I said that I was going to start today by grabbing you across the shoulders and shaking you, trying to get you to understand that what we've been doing so far in SQL Server is usually making things worse instead of better. So what are you supposed to do? Go set fill factor back to 100%. Stop playing around with that. If you've been crazy enough to set fill factor lower than like 80%, go rebuild the indexes on those tables, purposely setting fill factor back up to a higher number. When I'm working with clients, I'll usually tell them 100%. There's a good reason that that's the default in SQL Server. But if someone wants to say 80 or 90%, I'll just say, hey, as long as you're aware, you just made your database 10 to 20% larger, you made your memory 10 to 20% slower, you made your scans 10 to 20% longer. As long as you're okay with that, I'm okay with that. I get paid to fix slow things, you'll keep paying me, we'll be fine. But if they go below 80%, I'm like, no, step away from the controls. We need to do something better. And by doing something better, I need to explain how to monitor what SQL Server is really waiting on. Let's pretend that we have the world's simplest SQL Server, and it's only got one CPU core in it that can only do one thing at a time. When a query fires up, that query starts running and consuming resources while other queries line up behind it. And that query will keep running until one of three things happens. Either it finishes, or it uses CPU for 4 milliseconds straight. Sounds like a long time, but it's really not that long time for computer terms. Or it needs to wait on something, and that's the thing that happens all the time. Queries need to wait on things like storage, locks, latches, etc. And when a query needs to wait on something, it goes to the back of the line and it lets other queries proceed in front of it. Because of this, I care very passionately about what queries are waiting on. And I can ask SQL Server, just go tell me what queries have been waiting on. I don't care what CPU percentage is. I don't care what page life expectancy is. I don't care what buffer cache hit ratio is. The only metric that matters to me is, SQL Server, what have you been waiting on? What's stopping you from executing queries more quickly? And in order to understand how bad it is, I need to think about how hard SQL Server is working. If I have a query and it runs and then it finishes, there's no wait time. No other query is waiting on anything. It's just out the door. Imagine, for example, if you had everything cached in RAM, there was no locking, SQL Server could just churn through your query results without having to wait on anything, and it would be done. This server isn't really working hard. What about this server? Well, let's say that Jeremiah and Kendra's queries are both waiting on storage, let's just say. This server is starting to work harder. What about this server? Okay, now we're starting to run into problems. If I only have one CPU core and I got all these people that are all trying to run different queries, maybe some of them are waiting on storage, some of them are waiting on locks, some of them are waiting on CPU. Even if Brent's query finished quickly, I'd still have all this other work left to be done. The bigger that stack becomes and the more complex those queries are, the more things that are inside their execution plan that could all happen at the same time. With parallelism, queries go parallel across multiple threads. So with parallelism, you can totally see lots of things stacked up, even on just one query, where queries are waiting in order to get things done. It's perfectly normal in a really complex scenario with lots of complex queries running. It's normal to see for just one query, it's normal to see several things piled up on the right-hand side here that are all waiting on different stuff. Maybe some of them are waiting on storage, some of them are waiting on locks, some of them are waiting on latching, whatever. The bigger that list is over in the right-hand column, the more things that are waiting during any given period of time, the more screwed my SQL Server is. So I need a way to measure that. Let's say that across the span of 1 second, I have 15 things that are waiting on storage, 3 things that are waiting on locks, and 1 thing that's waiting on CPU. In 1 second on this one CPU core, how many seconds of wait time did I pile up inside the span of that 1 second? Let's make sure that I can actually see all the questions. I think, I have to do that from, I won't do that now. I guess I won't do that now. I was going to go look and see if I can do that now. That's okay. Oh, yeah, I can. Filter by all questions, sort by. Oh, good. You haven't asked questions yet. That's cool. So if I do that for 1 second straight, if I have 15 things waiting on storage, 3 things waiting on locks, and 1 thing waiting on CPU, that means inside the span of that 1 second, I had 19 seconds worth of waits. That sounds kind of weird from a math perspective, that in 1 second you could have 19 seconds worth of waits, but it's because your server can run multiple queries at a time, and each of those queries can have multiple tasks in it. Your server kind of sort of multitasks. That's where this graph comes from. Every monitoring tool out there, I don't care which one you use, all of them have this exact same graph. And say, for example, in the hour of 6 a.m., we had 19 things waiting for an hour altogether on average. We had 15 things waiting on storage, 3 things waiting on locks, and 1 thing waiting on CPUs. That first bar over there in the 6 a.m. hour is exactly the same as this scenario I just showed you. The higher that bar becomes, the more screwed our SQL Server is. You'll notice in 6 a.m. things were bad. 7 and 8 a.m. things got even worse. 9 o'clock they started to back down a little bit. And all of a sudden at 10 a.m. I spent way less time waiting on storage. I'm going to ask you a question. You don't have to type in the answer. I just want you to think about it out loud. Well, not out loud in the conference room. You'd be annoying to the person next to you. But think about for a second, what happened after 9 a.m.? What happened after 9 a.m. that we were able to suddenly spend way less time waiting on storage? Maybe people stopped working. Maybe people stopped their queries. Maybe people's reports finished. Maybe the overnight backups finished. Maybe the CheckDB finished. Maybe, I know this is going to sound crazy, maybe someone added an index. Maybe someone tuned a query. I know that doesn't happen often in your company because you're too busy going out to conferences instead of doing your real job. Except you paid to be here, so I guess that's kind of okay. That's our success graph. When we did things right, that number should go down. I'll give you a spoiler alert. The number doesn't go down when you rebuild your indexes. When you change fill factor, that number doesn't go down. What you need to do is you need to start tracking that number in SysDMOS weight stats. You need to see what your top weight type is, and then you need to make some kind of hypothesis as to what you could do in order to make that number go down. Then you need to do it, and you need to measure to make sure that it actually goes down instead of just making a guess. When you see wait time per hour at near zero, your SQL Server isn't doing anything. It's not waiting on that much. What you have to do is go to the people who are having problems with their queries and go ask them, what query are you having problems with? And then go do query tuning or index tuning in order to make a difference. The higher that wait time is, the more you have to focus on whatever the top wait type is and start doing performance tuning on that. To help, I wrote a stored procedure, totally open source and free, called SP-Blitz First. Should be the first query that you go and run when you're doing performance tuning. It is with me. I'll run SP-Blitz first. And for me, one of the most useful parameters on it is at the bottom of the screen there where it says since startup equals 1. SP-Blitz First will tell you since startup, since this SQL Server started up, what has been the number one highest weight type on my SQL Server. I need to look at that, whatever the top weight type is, and I need to go figure out how I'm going to make that weight type become smaller. If, for example, I'm waiting on locking, then I need to go tune indexes. If I'm waiting on parallelism, I need to go look at my parallelism settings and then go look at the most CPU and read intensive queries. If I'm looking at page IO latch, I need to go find the queries that are doing the most logical reads. If you've been focusing on fill factor, or if you've been wasting your time doing index rebuilds every night, that's not fixing any of this stuff. You got to look at what your top most resource intensive weight type is and then focus on whittling that down instead. That's going to be the thing that makes users high-five you in the hallways, is understanding which queries are causing problems and which indexes are causing problems inside your workloads. Now, it may come off that I'm like totally against index rebuilds, and that's not entirely true at all. Classic example, you're sitting out on vacation, having yourself a wonderful time like I am there, sitting out in Iceland on top of a glacier. And all of a sudden I get a phone call or a text from someone saying, and yes, I actually had text reception out there. Posted that picture live to Instagram while it was happening. I love Iceland. It's a magical country. And all of a sudden someone texts you and says, look, performance is really bad on the production application and we refuse to do anything because we say that it's a fill factor problem or an index fragmentation problem and that the fragmentation is so bad that performance isn't good. No problem. When someone believes that they're a database administrator and they're going to tell me that, I'll say, great, you got it. Can you do me a favor? Can you give me a query that's affected by fragmentation? Let's go measure it, see how long it takes and what its logical reads are. Then what I'm going to go do is I'm going to go rebuild indexes, and I want you to tell me how we're going to measure whether or not fragmentation was the reason that this thing got faster. Are you going to measure logical reads? Are you going to measure query runtime? What's going to be the thing that you're going to measure before and after to prove that this thing worked? And I'll give you the spoiler alert. You only have to do that with someone once. And they learn really quickly that rebuilding the indexes isn't the thing that got them across the finish line. Often, if it's a parameter sniffing issue or a statistics issue, the fix is something completely different, not rebuilding the indexes. And even just freeing that plan cache can get you out of that, past that bottleneck, rather than doing that disk-intensive work of rebuilding all your indexes. So now if you stop doing index rebuilds every night and you shift to every week or once a month, what should you do with your nightly maintenance windows instead? I get so worried about database corruption. I get so many panicked phone calls and emails from people who say I had a storage problem, especially in the day and age of the cloud. My storage disappeared from out from under me. My data pages are corrupt. I was the victim of a SQL Server bug. Read the cumulative update hotfix notes. There are corruption bugs and fixed in many of the cumulative updates, even in SQL Server 2019. It's not just when the server goes down randomly or someone has a cable problem. SQL Server itself can introduce corruption. And let's say that you run into database corruption sometime over the weekend. On Sunday, the database corruption happens. But I say you run into it, you don't know that it happens. It's not like when database corruption happens, you get an instant email. No, you find out when SQL Server reads the pages that were corrupt. But when storage hoses up the data, or when SQL Server itself hoses up the data, it's not like you immediately get an email. And let's say that you're doing full backups once a day and you're doing log backups all day long. Well, time goes on past, and on Monday, someone actually reads that 8K page that was corrupt. They run a report, they get an error, sorry, could not continue, database corruption, contact your database administrator. But of course, they don't call you instantly. They wait a few times and they run the report a few more times, and then eventually they tell you. But if you're the kind of shop that only keeps the last 24 hours of log backups, you can't go back and restore. You can't go back and restore from before the corruption happened because you've already deleted all the log backups that you need in order to recover. When you're facing database corruption, you can't just restore the last full backup. The corruption's in there. You have to restore the last full backup that you knew was clean. And so often I see people going, I'm going to rebuild indexes every day, but I'm only going to run CheckDB once a week. And then they're only keeping a limited amount of log backups. They're going to lose days worth of data when it's time to recover from corruption. This only has to happen to you once before you start asking the question, what could I do in order to lose a whole lot less data? And the answers are really simple. Run CheckDB more often. Run CheckDB, I would humbly suggest every day. And yet I know people, when I give that suggestion, they're like, I can't. I have to do my index rebuilds. Why? You're not fixing anything. All you're doing is shuffling 8K pages around and users aren't noticing the performance difference. You're wasting your time. The company didn't hire you to fix fragmentation. The company hired you, DBA, database administrator. The company hired you to administrate their databases, and part of that is making sure that you lose as little data as possible. Database administrators never in history have gotten fired for slow performance. Quite the opposite. You get training money for slow performance. Your manager will say, hey, we need you to work a little harder on performance. Can you go to a class maybe, or can you buy a tool, or can you read a book? Can you spend an hour trying to figure out how to performance tune this query? There has never been a human resources case in history where the human resources person calls you in and says, all right, unfortunately, you haven't been able to get this query down from 80,000 logical reads to 10,000 logical reads. I'm afraid we're going to have to let you go. No, database administrators get fired because they lost data. Database administrators get fired. It doesn't happen often. But when they do get fired, they usually get fired for, well, let's be honest, drinking on the job. We get fired for drinking on the job because our job's really hard and sometimes it sucks pretty bad, so we have to drink. And as far as you know, this is coffee inside of this coffee mug. Delicious coffee. Database administrators get fired for losing data when you have a ransomware attack, when you have database corruption, and it turns out that you don't have good backups or you weren't actually doing DBCC CheckDB as often as you thought you were doing it, or in a manner fast enough to where you could actually recover the data quickly. What I would humbly suggest for database administrators out there, spend a lot less time worrying about fragmentation, a metric that doesn't even matter in most cases for external fragmentation. And instead, you start focusing on how much data you might lose every day, which happens way more often. So to recap what we talked about inside here, first, external fragmentation means your 8K pages aren't in order on disk. That hasn't mattered for 10 years or more because your storage is shared between lots of SQL servers. All storage access these days is random, especially even more so when you go up to the cloud. You don't really think that Microsoft is giving, or Amazon or Google is giving you your own drives. These are drives that are shared across all kinds of people. You're doing random access all the time. External fragmentation simply doesn't matter. Internal fragmentation, aka empty space on the 8K pages, does matter. Internal fragmentation is bad because it makes your database larger, makes your scans take longer, your maintenance tasks take longer. But when you set fill factor, you are setting internal fragmentation. You are making the database longer. You are caching empty pages, flushing memory down the drain. That is the problem, not the fix. So I would suggest that for the fix, you set fill factor back up to 100%. Cram your data in with as much sweet, juicy data in on each 8K page as possible so that your backups are faster, your database is smaller, your scans take less time. It's way more likely that those 8K pages will be stored in RAM. And instead of rebuilding databases every day, trying to fix a problem that you don't even have, instead, focus running on CheckDB more often. And if you want to make your end users happier in terms of performance, go focus on whatever your top wait type is and look at the queries that are causing that top wait type. All right, now I know that this is one of those grab you by the shoulder sessions and shake you and get you to think all kinds of different things. Now's the point where you can put in questions. For those of you who are online, you can ask questions over in the Q&A tab over in Whova. And those of you who are in the room, I suppose you can answer questions or ask questions out loud. And I believe the folks with the microphones there are going to take the questions. Let's see, there's nothing in the questions in Whova. We'll see how that goes. Give you a few minutes or a minute or two to go ask questions. And it doesn't look like we have any questions, so I think we're good to go. So thanks everybody for hanging out with me today. If you have questions that you want to ask afterwards, feel free to go to brentozar.com and ask the questions up at the top there. I hear a voice, I see. Okay, yes, go ahead.
No, I just tried to ask if we have any questions in the room, but it seems that there is no one.
Everybody's scared now that I had that come to Jesus talk. Well, thanks everybody for hanging out with me this morning. I hope that you had a great time and enjoy SQL Day in Poland. Adios, folks.
Okay. Thank you very much.